Stanford research frequency generator 50 Hz, Agile frequency counter 49.999, frequency generators, quartz locked like yellow trace, and blue it is 50 Hz, Latvian ergo. When on scope blue signal drifts to the right, then frequency is less than 50 Hz.
Alternative representation, Lissajous figures.
There was complication to record in computer, simple USB sound card, it had only one channel, but I want two channels. So I connected USB sound card. It is double task for the power company, they need to keep frequency 50 Hz and as well as amplitude stable. And I can notice that amplitude walks around a little bit. This small dip, it is some voltage excursion. Power spectrum, we have the main peak at 50 Hz, and then we have odd harmonics, 150, 250, and so on, every 100 Hz. February 3, 11 o'clock in the night. Arduino program ready, it's counting cycles and plotting out in 1 minute intervals. We have excursions of 10 cycles at 20 minutes. In the night, network has become more unstable. Probably some power station is switched off. We have actual frequency below 50 Hz, and in the web page it was also below, now it's above a little bit. Here is Estonia electricity, the Swedish website, and here is Swedish stability. So far largest excursion recorded in Swedish network tonight. In Latvian network overnight there was time when 2 cycles per minute were sleeping. There are normally 3000 cycles per minute, so 2 cycles of 3000, it's quite a small fraction. Baltic countries in the night most expensive electricity, €122. Latvia production of electricity, thermal power and hydropower. Saturday morning, almost 10 o'clock. Everything looks fine. Also, there has been no cycle slips or switching off power. Everything is continuous over 5 days. On Swedish grid they say 0. And on Latvian grid they say 0. Now the frequency is lower than usual slightly, but within margins. Now there is 0 from Estonia to Russia, and time is 9:55. We can see a small deviation from sine wave here, where 0 crossing appears, and here is also delay. So there is something which delays the sine wave in time, tries to break it a little bit in time. So this is the effect of harmonics. And on the top we have kink, which is faster than sine wave, so it tries to accelerate. Situation on Monday after synchronization. Quite large drift, quite strong drift. Frequency below 50 Hz. The top and bottom of sine wave looks flattened. My study over 9 days has come to an end. It started on February 3, when we were still synchronized with Russia network. Arduino was counting cycles and adding cycle with +1 when it came from grid, and -1 when it came from 50 Hz quartz. So on vertical axis is cycles in 1 minute, how much differ from 50 Hz. And on horizontal axis is time. One 24-hour period is 1440 minutes. And in the first days we were synchronized to BRELL network. We see some changes with step-like character. On Saturday, February 8, desynchronization came, disconnection, and during days there was rapid frequency change test, which was announced on the website. And Baltic countries were running on isolated island mode, and during this time frequency was higher than 50 Hz slightly, which gives a reserve time if something starts to break down and slow the frequency. And here we synchronized to European network, and we see periodic waves with several hours period, and European grid ENTSO-E has more rapid spikes than before in Russian network, but yeah, the quality of grid is within specifications, and It's not bad, it's just slightly different behavior. And congratulations, it was great job. No power outage, no discontinuity into phase during a transition period from BRELL to ENTSO.